Magandang araw at tayo ay dadako na sa susunod nating topic which is limits. So itong limits na to ang basic foundation ng derivatives na ito naman yung highlight ng ating course na differential calculus. So magsisimula tayo sa instinctive idea ng limits. So start tayo by considering this function. So function f of x is equal to x cubed minus 7x minus 6 all over x plus 1. So, dun sa nakaraang discussion natin sa domain, so it's clearly seen na kapag ang value natin ng x is equal to negative 1, hindi magiging defined yung function natin. So, diba, sabi natin kapag ganito, yung denominator natin na x plus 1, i-equate lang natin sa 0 at yung makukuha nating value will be excluded from our domain. So, therefore, x must not be equal to negative 1 para maging defined yung ating function. But let us try to inspect and explore the function values as it gets closer to x is equal to negative 1. So I have here a table of values for this function as x approaches negative 1. So as we notice na kapag nag-substitute tayo ng negative 1.1 sa original function natin, so that is negative 1.1 cubed minus 7 times negative 1.1 minus 6 all over negative 1.1. So, ang makukuha nating value ay negative 3.69. Doing the same, habang papalapit tayo dun sa negative 1, negative 1.01 naman. So, substitute natin siya dun sa ating f of x. Ang makukuha natin ay negative 3.967. So, lapit pa tayo ng konti, that's negative 1.001. So, pag sinubstitute natin, ang makukuha natin ay negative 3.997. So, kung mapapansin natin, habang lumalapit siya dun sa negative 1, so this is negative 3.69, magiging negative 3.967, magiging negative 3.997. So, habang lumalapit, mas nakakakuha tayo ng value approximately equal to negative 4. So, pagka naman galing tayo sa kanan, kuha tayo ng greater than negative 1. Let's say, let's start with negative 0.9. So, pag sinubstitute ulit natin, makukuha natin negative 4.29. Lumapit tayo ng konti. That's negative 0.99. So, magiging negative 4.030. At lapit pa ng konti, that's negative 0.999, that's negative 4.003. So, approximately, equal pa rin siya sa negative 4. So, nagkakaroon tayo ng fixed value ng f of x as we get closer papunta dun sa ating x is equal to negative 1. So, please take note that when x is equal to negative 1, our function will not be defined. So, as we try to graph that, so, ang mappo-form lang pala is a parabola, simple function na makakabuo ng parabola na ang point na negative 1, negative 4 must be removed. That's why, kung makikita ninyo, this is a circle. So, that is negative 1, negative 4. That point, negative 1, negative 4 is being removed from our graph since x must not be equal to negative 1. So, the value it approach is equal to negative 4. So, punta tayo sa definition ng limits. So, sa definition ng limits, let f be a function and let c be a real number such that f of x is defined for all values of x near x is equal to c. Dun sa ating kaninang example, near x is equal to negative 1. So, except possibly at x is equal to c. Of course, clearly see naman natin kanina that x is equal to negative 1 is not part of our domain. And L are fixed real numbers. Yun yung negative 4 na nakuha natin kanina. Then the limit of that function f as x approaches c is the number L. In symbols, we write limit of f of x is equal to L or limit of f of x as x approaches c is equal to L. So therefore, kung ating titingnan yung example kanina, that limit of our f of x as x approaches negative 1 is equal to negative 4. So kasi parehas yung or nagiging fix yung real number na nakukuha natin habang lumalapit tayo dun sa value na x is equal to negative 1. So, let us try another example. So, I have here limit of a linear function 3x minus 5 as x approaches 2. Since this is a polynomial, alam natin that there is no restriction sa ating domain. So, our domain there is a set of all real numbers from negative infinity to positive infinity, open and close parenthesis. If we try to graph the function, we can see that the values approaches to a single or a unique value of y as x approaches 2 is fixed. So, as clearly seen in this graph, na yung value na ina-approach papunta dun sa x is equal to 2 ay fixed number, real number, which is equal to 1. So, unique yung value ng function natin na nakukuha as it gets closer to x is equal to 2. Thus, the limit of 3x minus 5 as x approaches 2 is equal to 1. So, ibig sabihin, paano natin kaya ito marirelate sa function value? So, let us try to check this out. So, limits and function values. So, meron tayong dalawa dito. Yung una, f of c is not defined, but the limit of f of x as x approaches c is defined. Tulad ng example natin from the previous slide. Yung limit of f of x as x approaches negative 1 is equal to negative 4. Indeed, this limit is defined, but the function f of negative 1 is not defined because, again, negative 1 is excluded from the domain dun sa first example natin. So, itong pangalawang example natin, that limit of 3x minus 5 as x approaches 2 is equal to 1, f of c is defined because once you substitute f of 2 on this function, that gives us 3 times 2 minus 5. And that gives us 6 minus 5, which is equal to 1. So, f of c is 1, and the limit of f of x as x approaches 2 is also 1. So, f of c is defined, and the limit of f of x as x approaches c is equal to f of c. So, meron lang tayong bibigyan ng emphasis na kapag yung L na nakuha natin ay hindi nakabelong sa ating set of real, we can say that the limit does not exist. So, meaning to say, kunyari, ang nakuha kong L ay infinity. So, infinity is not a real number, so therefore, the limit does not exist. So, let us try to compare these two functions. I have your f of x is equal to x minus 2 all over x squared minus 4. And another function, g of x, 1 over x plus 2. So, please take note that this function, f of x, ay hindi magiging defined for x is plus minus 2. Kasi pag kinuha natin ang root ng denominator, magkakaroon tayo ng plus or minus 2. And again, since nasa denominator siya, hindi siya pwedeng mag-0, kaya these values of x are excluded from the domain. So, pag titingnan natin ang graph, so at x is equal to negative 2, so I have here a dashed line which represents the vertical asymptote, and of course a circle there which represents that x is equal to 2 is not included from this domain. So not defined yung function at x is equal to positive 2. But kung babalikan natin yung na-discuss natin kanina, so yung value na na-approach natin as it gets to x is equal to 2 ay napupunta lang sa iisang unique value ng y, which is in between 0 and 1. So we can approximate it here as, say, 1/4. So the value it approaches is a defined number L, which is 1/4. So let us try naman to investigate this g of x is equal to 1 over x plus 2. So here's its graph. So again, for this function 1 over x plus 2, so ang domain nito, dapat ang x must not be equal to negative 2. So that's why, as you can see, etong dash line natin na color green, it represents the vertical asymptote. This time, defined na tayo at x is equal to 2. Kasi pag sinubstitute natin, 1 over 2 plus 2, that gives us 1/4. So therefore, ang y value na ina-approach niya ay 1/4, which is actually equal to your f of 2. So yun yung kanina natin na generalization kanina. But, so kung titingnan natin pala ito, so kung isi-simplify natin itong f of x, I have your x minus 2, x plus 2, x minus 2. And that x minus 2 cancels out. So which gives us 1 all over x plus 2. So same lang yung dalawang functions as you can see. So the only difference is that dito sa f of x, may additional restriction tayo that x must not be equal to 2 as clearly seen on this graph. Pero parehas ang nakuha nating value, kaya ang limit ng f of x as x approaches c is equal to limit of g of x as x approaches c, irrespective kung siya ay defined at x is equal to 2 or not, provided na yung value it approaches is a finite or a unique y valued or function value. So, but what if kung i-check natin siya as x is equal to negative 2? So what if i-ano natin siya at x approaches negative 2? Investigate natin yung function value at x approaches negative 2. So since asymptotic ito, as it gets nearer, it gets closer and closer to that particular line, but it will never crosses or touch such boundary line. So ibig sabihin, kahit mataas ang or kahit saan magdating ito, ang range niyan ay hindi pa rin siya magta-touch dyan. So ang value na ina-approach niya is infinity kung galing tayo sa kaliwa. Ito naman sa kabila, pag from the left of x is equal to negative 2, ang value naman na ina-approach niya ay negative infinity. So, di ba, ang sabi natin kanina, kapag ka ang limit or yung value na ina-approach ay hindi defined, or meaning to say, hindi siya part ng set of all real numbers, therefore, the limit at x is equal to negative 2 does not exist. But we will surely investigate on that further in the next session. So that's all muna, and then I'll see you on sa susunod na video.